Yeah, as we discussed, Dave is going to do a few announcements. We have a few people that we like to mention on the show. There's been quite a few events. We see a lot of activity on LinkedIn from Automate still. I think people are still posting pictures, video. There's been some promotion for the cobots. I don't know, Dave, you saw the picture next to the Eiffel Tower. We're
I
hoping
don't think I
Caleb.
saw that one.
It's a new UR robot, Caleb. I don't know
You
if you've seen it, but I think
you
they're
are
releasing. Yep,
you are 20. Yeah.
You
it's
are
the
20.
I think it's the
Interesting.
largest in their lineup.
Yep.
On a side note, while we let people trickle in, Dave and I have spoken to have like a cobot discussion because we've talked about robotics earlier in the year. But I think cobots is an interesting segment to explore. So we're certainly are trying to find people to talk to in that space and seeing what value cobots are driving in manufacturing. But Dave, I'll let you take the mic from here.
Absolutely. No, welcome everyone to Manufacturing Hub. We have somehow made it to another Wednesday, which if you're like me and woke up at 3 o'clock on Monday morning in the attempt to get on an airplane and got on an airplane almost 20 hours later to take the red eye because your first airplane was delayed 12 hours, you will also be shocked that we have somehow only managed to make it to Wednesday this week. But no, so we're super excited to continue into the IIoT theme. We do want to make sure to thank Phoenix Contact for sponsoring this theme, for Ira for eventually allowing us to kind of twist his arm to come on the show after asking for, I don't know, the last 60 episodes when we could possibly get him on. But it's been an amazing theme. We're excited to talk about a bunch of additional applications. A couple of quick notes. As Vlad alluded to, there are a ton of trade shows going on. Vlad certainly has FOMO or whatever FOMO is after you've missed out, but people keep posting the pictures of the trade shows and the videos of the trade shows they've been to. So if you guys are going to be at some interesting trade shows, let Vlad know. I know Vlad wants to go to a trade show. I'm not sure what I will be. Oh, but talking about shows, so I think it is next week is CSIA is out in Denver, which should be a good show. I sadly will once again be missing it. I find every time CSIA has an event, I was there like 2 or 3 weeks before them. So I will sadly be a little late or a little early for CSIA again this year, but you guys should definitely go ahead and check that out. I think they sold their hotel block months early. So I think it's going to be a busy show. I know there was a little bit of worry at the beginning of the year of will there be people who go to trade shows? And I think the answer is after a few cancellations, people are going in droves, if only because they miss taking pictures to make Vlad feel jealous. So if you've got some exciting trade shows to go to, drop them in the comments below. We'd love to know where you're going. Potentially, we will find some time to meet up at one of those. A couple of awesome things happened. So recently, Frank Lamb on Mastering the Machine did project testing. I will go ahead and drop that link in the comments. Now, sometimes, and it may just be this industry, I feel like people are like paying attention to the projects that I'm working on, and they like release the thing that I am working on or talking about either like 2 days after or 3 weeks before. And so this and then project management, which is what Frank talked about a couple of weeks ago, were very topical for some of the things that I'm working on. And then one last thing. So Caleb, I like to embarrass Vlad. Vlad has a successful YouTube channel, Solus PLC. We'll wave hi to Solus. They crested 31,000 subscribers, and Vlad doesn't like asking people to subscribe to his own channel. And so I feel like if we ask people to subscribe to the channel, we get to take all the credit for all of the hard work Vlad has done. So
Thanks, Dave.
Absolutely, Vlad. So on the subscription side, please go ahead and subscribe to Solus PLC. If you guys are watching from Solus PLC, hi again. Thank you guys for watching. We love to have you. And then while we're asking for subscriptions, I have found that this podcast does a lot better if I ask people to subscribe and download and do all of those things. So you guys can catch us on manufacturinghub.live, which is where you'll find all of the collateral videos, audio for this show number 66 and the 65 before it, and the 20,000 that we will do into the future. So podcasts and video form, you guys can go ahead and subscribe to Manufacturing Hub Network on LinkedIn. So we crested 1,000. We're almost to 1,100 followers, which is pretty awesome. You guys can get updates and clips on there. Follow Vlad and myself. Follow Caleb. I guess we'll let Caleb talk a little bit later to see if he wants people to connect with him online. But follow all of us. And then if you're listening in podcast form, please go ahead. Let's see. You can rate us 5 stars on Audible and Spotify and Apple Podcasts. Yes. I learned that from actual podcasters that I listen to, but we're like semi-professional at episode 66 of our weekly show. So I feel like I can go ahead and say that. So please go ahead and do that. It helps the algorithms for reasons that we're just not going to talk about and probably never will on that show. But without this, let's jump into it. Again, everyone, welcome to Manufacturing Hub. I am Dave. This guy up here is Vlad. We have a very special guest for episode 66 to talk about IoT, Caleb Eastman. Caleb, thank you for being here.
Thank you for having me.
Appreciate you joining us today, Caleb. I want to, before we dive into the technology piece of our discussion, I wanted to get your background a little bit. And I know we've talked a bit off stream. You have I would say, an unconventional entry into manufacturing. So I want to hear your backstory and I guess understand what made those decisions and I guess also the story of who made that possible.
Thank you. So I guess, the kind of what started it was in high school. My school had a program for Cisco. It was a Cisco Academy. We kind of graduated high school with a CCNA, and wow. I got that, and actually was getting ready to go to college to get my CCNP or CCSP. And had a full ride to a university and decided at the last minute, no, I thought it would be more helpful to people if I were a firefighter. So I instead went and enrolled in a fire science program for Hutchinson Community College and fought fire a little bit for the Forest Service as a wildland firefighter. And so didn't just kind of set my, the network engineering thing aside. And that ended up coming back up when I got hired by a small oil and gas company in Southeast Kansas to do their networks, particularly their tower networks, their OT networking, and got into SCADA that way. And kind of that was the actual beginning of the career. Really,
if you don't mind me asking. Sorry to interrupt. What made you decide to go back into, I guess, like controls and networking? Was there like a decision point? Was it just, I guess, a good opportunity? Or what was it like, I guess, to rethink going back into the tech world?
I really what it was is that it's hard to explain. I guess it was just that I had kind of missed tech for a lot of my 20s, and just kind of wanted to kind of get back into it because I was okay at it in high school. And so I kind of accidentally fell into it, happening to work for a company where the networking and that I was doing was OT related, and I'm really interested, as it turns out, in complex systems. And so I wanted to learn about the control systems, and I wanted to learn about SCADA, and then what happens to data after SCADA, and how all the components work together. And so so after that, I co-founded a systems integrator and an electrical shop, and that takes you into basically everything. Like if you're a systems integrator, it's very easy for you to carry it into all sorts of connectivity issues and control issues. And that's where I kind of fell in love with PLCs, and from there I was recruited to go work for a company out of Silicon Valley that was sort of kind of in a lot of ways adding the AI component to it, and then after that I co-founded with Valerie, who's my wife and the CEO of the company, WinterWinds Robotics, and so got a lot of opportunity to do more in the robotic space, obviously with WinterWinds, and I've gotten to do some cool things with NASA and some large Fortune 500 companies. It's been a fun ride, I guess is the best way to put it.
I'm really excited to dive into more as to what you're doing today at Win Robotics, but I do want to, I guess, like point out, or I guess like comment a little bit, that it's interesting that a lot of times I think controls engineers or people on the OT side, at least in my experience, don't know networking that well, and usually try and supplement that knowledge with a CCNA, right? Or try to learn the networking aspects after they've done controls, versus you come from the other side, whereas you knew networks really well, and then you've learned all the OT systems down the road. And again, I think it's just an interesting perspective, and I think that there's certainly, I would say, a lack of knowledge in our space when it comes to networks. And like I could tell you, even, CCIE is probably, the next level, but even just a fundamental understanding of how manufacturing networks should be laid out. So that's just a very interesting observation, and I think it's not often that we have people sort of like coming from the IT side going into OT. So that's really cool.
Yeah, and it's actually super useful, particularly in the highly distributed systems that comprise of energy systems, because like if you're someone who's willing to go out to the middle of nowhere and you can completely replace a Cisco switch from a tower where the whole tower got knocked out by lightning, and you have to replace all the components and reprogram the Cisco switch, things like that. It really does help in those scenarios, because one thing that's traditionally pretty hard to find is people who can do that type of stuff, and also are familiar with wearing hard hat and FRs, and things like, and can find a tower in a rainstorm in the middle of the night in West Texas or Eastern New Mexico in the middle of nowhere. So yeah, it was a lot of it's been a lot of getting woken up 4 a.m. and going to have to fix something type stuff. But I know that we've all been there. So
Caleb, so I guess going or fast forwarding to today, could you give us a picture or what it is that you're involved with? Again, I don't think we need to mention any of the companies, just in case they want to remain anonymous, but what kind of work are you doing with robotics, IoT, Industry 4.0, and I guess AI ML in general?
Yeah, so I'll give an example. So for this year, we're actually working with NASA on there's a common problem or an unknown problem in wildland fires is that when the aerial operations are occurring, if a drone enters the area that's like just some dude wanting to get a good close picture of the fire, enters the area, all the aerial firefighting planes have to ground. They have to all stop because it's not managed the same way that typical air traffic control is managed, because it's a very localized issue. The planes fly very close to the ground, and it's a moving situation. So as the fire line moves, or the firehead moves, usually west to east, sometimes other directions, the operations change as well. And so we're helping to sort of modernize the process by which they currently do that by setting up an ad hoc radar net that effectively is sort of a synergized point cloud for the area. And the main reason is to sort of coordinate the firefighting operations as it relates to ground operations, but also to detect undesirable drones in the area, unmanned systems in the area that tend to create a lot of grief for the incident command team. That's an example of something that we're doing right now. That is IoT, by the way. It's all the same problems. That in I'm happy to argue with anyone about that. But related to more traditional controls, we're working with a large company on helping to deploy a sort of an edge computing novel sensing platform into their OT environment. We tend to sort of, and there's a lot of sort of, it's a very distributed environment, and a lot of hazardous locations, and so we're working with them on solving those problems. For ourselves, the way we kind of work is we're a services company that is taking any profits we make and funding our own internal development from products as well, because we like to do research and development, and we're making a novel vibration sensor for condition monitoring. So that's another example of an IoT thing we're doing. So
That's really interesting. I like to hear examples, I want to say, that are unconventional or that are not obvious to someone who is, I would say, like stuck in a plant, right? And looking at the digital or analog sensors just being passed to a switch, and then that switch just funnels them into like a database. And I would assume that in those like firefighting operations, obviously there's that component, but there's also, as you've mentioned, there's a lot of different noise. It could be physical devices that are obstructing whatever operation. So it's interesting to see. I would say that IIoT is not just data coming in from plant sensors that are all wired in. There's a lot of different applications that I think people may ignore. But I wanted to ask you, I guess, fundamentally, and we've asked this question from all of our guests on this theme, like, what does IIoT mean for you? Because I think in our current space there's a lot of confusion. If I'm asked that question, I even talk about various technologies, right? But I think it always kind of boils down to still having a hardware presence, right? Because it's Internet of Things. So it's hardware that's connected to an Ethernet, I guess, or Profinet, whatever protocol, but it sends data to a database, right? But is there maybe some technologies that you would think are core to when you're discussing IIoT?
I consider IoT to be a rethink of the way that you measure and process, measure and consume the data that's coming from your physical process. So an example, I consider, for example, IO-Link, the technology, as an IoT concept, because you might today have a 4 to 20 milliamp, 420 pressure transducer on one of your processes, and it sends back that single variable, and that's all the context you have. And if you were to replace that sensor with an IO-Link sensor that does the same thing, but now you have raw ADC counts, you have diagnostics, you have faults, you have soft alarms, you have automatic reparameterization, you have that context at the sensor level, that would be what I would consider to be an IoT initiative. That's an example that sort of basically it's creating more context, or creating more context between the sensors and the edge, if you will. And I'm happy to include the cloud, but the sensors to the that enables other initiatives, whether it's AI ML or sort of down the line.
And it's interesting, to be honest with you. Again, there's a lot of debates around protocols. There's a lot of debates about different ways of processing the data. I think there's going to be a lot of debates, maybe even controversial comments around IO-Link. I certainly think that there's never enough data. Obviously, there's a caveat that we should be using the data that we're consuming and understanding it better. But I really like I guess the concept of contextualized data has always been on the back of my mind, because I think, and maybe I would like you to elaborate on this, there's many initiatives where you funnel a lot of data into a data lake, database, whatever you call it, and then it's just way too difficult for someone at that level to be able to extract information, right? And I, I'm wondering if you have some examples or want to, I guess, like expand on that topic. But I think just applying, I would say, big data principles, or again, like AI, ML, like whatever you call it, doesn't always work the way we would expect, right? In traditional, I would say, methodology. Any
Yeah.
thoughts?
So I think the key thing is to understand that there's never magic, and whenever we put anything in a black box and we think that it's magic, then it's going to disappoint us. So the concept, one of the more recent sort of magical concepts that I think has sort of infected the industry is the idea that you can hire a data scientist, who has a background in Python and maybe an understanding of neural nets, and you can just shove the data at them, and they're going to come up with like sort of a brand new insight or whatever. And I feel like, and particularly I've noticed it's like sort of the executive level, the people who sort of are financially responsible for the plant and not necessarily familiar with the lower level controls. And the issue that you find is that the data scientist has the least amount of context in terms of what that data means, what that data is, how that data normally looks, what the data. So expecting them to sort of create some kind of magical model that will, increase your efficiency by 15% or something is difficult, is troubled. Like you might get there. I would contend it's probably luck if you did. So I won't say it's impossible. I'll say that it's statistically unlikely, right? Which is, I guess, ironic because data science is based on statistics in the end of the day. So I, and there's been, and there's been a desire, kind of the last 10, 15 years, it seems like, you mentioned big data as an example. It seems like the attempt that was made is that what we'll do is we'll present the existing data we have with no more context than it currently has, or maybe even less, because, maybe even less. And you kind of push it a different direction, like push it at an Azure data lake instead of a PyHistorian, or push it into and kind of hope that someone 6 months from now will be able to make sense of it later. And I feel like we've kind of cycled back to where we should probably all admit to ourselves that we should have a look at what we can do if we originate the data with more context. So I think there's two things to that. One is novel sensing, and by novel sensing, I mean types of sensors that we traditionally aren't deployed in control systems, such as depth cameras, high frequency radar. And then in other cases, it's to have a look at the sensors that we currently have and think about, like, is there a way? IO-Link is an example of that. Is pretty much anywhere that there's a single variable sensor, there's probably someone makes an IO-Link sensor of that thing, which gives you much more information about it. And I think that if we kind of want to hit the next, and this to me is a sort of a plan for the future type scenario. What we probably could know as an industry, and is that the likelihood of people involved in it, particularly operators, it's very likely that we're going to lose context from the people who've been doing this for the last 30 years. Mm-hmm. And we're going to replace them with young people out of, I'll just say it, Gen Z people who are less willing to get that context and to spend the amount of years on that process, and more interested in technology or using technology. And so we have to start building that context kind of into the system. and originate it starting at the sensor level, or else we'll, if we rely on the current sort of makeup of skills, then we'll gradually lose our ability to run our own systems. And this, by the way, is not the first time this has happened to humanity. This is what happened with the Roman aqueducts, as an example. Is the people who originally made it knew how to run them, knew how to operate them, then they ran. Like, there's this assumption that as a society we are always getting better at technology, but there are many examples historically where we have gone backwards in technology because of a lack of context. And that's so because knowledge was not passed from generation to generation about, and so I see a scenario in which our infrastructure starts to fall apart because people don't know how to run it anymore.
That's a very interesting thought. To be honest with you, I'm not sure I have the answer, but I would definitely agree that, it's not an obvious, I would say, like, answer, right? Do you need to upgrade the instrumentation, but then who's going to, I think there still needs to be someone who understands the process really well in order to, I would say, add context even to individual sensors, right? Because I think that technology alone is not going to solve that challenge. And so, in the example that we talked about a bit earlier, where you have a data scientist presented with a lot of data flowing in, well, he needs probably several process people from, again, different areas, different departments that truly understand what's going on. And then you probably also need controls people who understand the data flow, right? Because again, at least like in my experience, there's still a disconnect between someone who understands the process really well and then someone who just focuses on controls, and then someone who does data work, right? And so I don't know what's the solution for every end user, but I think, as you said, they're going to have a harder and, I would say, like, more challenging time to find people to fill those roles. But also, the 20 years spent at a factory, it's going to be, I don't think it's going to be the norm, or at least, like, I've not seen it being the norm for, like, my colleagues, at least.
I'll definitely say that, like, as time goes on, I think that people who really understand processes and really understand controls will be able to name their own price. My concern is that there simply won't be enough of them, and so I'm planning on, and so part of it is education. So Valerie, the CEO of our company, she started her career as a teacher, and so her answer would be is you have to have an incredibly structured education program starting now, and really putting people through those, the processes and controls, and
And I guess you're not referring to like traditional college. You're referring more like, if you're a manufacturer, you should have a structured, maybe like mentorship type of a program where you're paired with like a more senior guy. Yeah, just to clarify for those listening.
I mean, I would really like anyone who has. I would please contact me if you've met a college graduate from any of the colleges that is ready for it, that doesn't need this, what you're talking about, that incredible amount of mentorship around. Like they don't teach them that stuff in college, and they can't anyway. It kind of requires that you have the heavy machinery around, and so absolutely, I think that everyone should have a robust education program for their process, robust documentation, a lot of context, a lot of deep understanding. Make sure that you capture that information, that knowledge, because it doesn't just happen. Like, and so to me, I think a lot of people when they talk about IoT, they talk about how we can use IoT to make things better than they are now. I think about it as we need to have an incredible amount of investment in things like this in order to not make things worse, because entropy as it relates to knowledge is a significant issue in this industry, and in my opinion. And if anyone disagrees with me, then I'm happy to like. It's a big deal, and it's a big problem that we have, and I think it's going to be increasingly market. And the main concern I have is that this is one of those things where if we're not solving for those problems, like, man, it'll be bad in 10 years. Just imagine what it will be like if we just let things go the way that we're going now, as it relates to the supply chain and all how society runs on what we're doing. Like to me, we have to safeguard it with that. It's sure, increasing efficiency is great, but society runs on what we're doing. We have to safeguard that for the future. And it doesn't appear as though we have a plan as a group, as an industry, if you will, right now.
I would agree with that. And I think, I'm sorry, Vlad, Caleb has made a bunch of good points, and I just want to make sure to tag on and tag on to a couple and dig into a couple. I think kind of Caleb's comment of context being key, like down to the sensor level is important. I would kind of go down that path slightly further. And I feel like it's not that we need to make sure that everything has the most perfect context always. I think it becomes a point of, if we don't start contextualizing what we're doing now, and if we don't capture the last 10 or 20 years worth of work, no one will have any hope of being able to understand it in 10 years. And in 10 years, you're rebuilding the whole thing because there was a sensor in one area for a very particular reason. But now here we are, and we don't know why there's a sensor here, and no one ever documented it, and no one ever contextualized it in the database. And so it runs into, we would just have this huge knowledge gap. And to Caleb's point about training. So Tim is in the chat. Tim Wilborn and I have had many hours of conversation on training and everything along those lines. And for me, whenever I talk about training, for me, it becomes, how do we pull the information out of the people who have been here? So I have clients who have people who have been working on the same things for 45 years. They're the world's expert because they've probably outlasted everyone else who was there even close to the beginning. And most of the time, those people, they don't even want a flip phone, right? Like most of the time, if you want to get them in the facility, you're getting them on a walkie-talkie. If you want to get them outside of the facility, you're probably calling the home phone. And so as we go look to bring this generation, the next generation, and then generations following, it becomes they're different people. They understand things differently. So we need to pull the information to build training programs so that we can provide context, but we also have to look at how we can pull it out in fun, new, interesting pieces of technology, because if we don't use technology, we'll have already lost people before we get them halfway through the training program.
Right. Like, as an example, I've long thought that, like, anyone who has someone like what you just mentioned, someone who's been around the process for 45 years, if they think that's just that when that person disappears, that it's just going to be okay, like, that's crazy, right?
Yep.
So if people like that, I've long thought, like, you should hire some, young kid who's still in college, out of college, whatever, follow that person around for weeks, months, if you can, and have them document and write down and learn what that person knows. Because I found oftentimes those people that you don't even, like, you can't just, like, you can't document what they know unless you're seeing it applied, right? Like, because they don't even know, like, they don't even necessarily think about, like, if you were to ask them, tell me everything you do in a day, they may not be, like, until they get in. So I am very worried about the loss of those people, and it's happening, right? In at least one sector, I know it's called the Great Crew Change, where this phenomenon where you have these people that have incredible knowledge about the process, and we're willing to obtain that knowledge through years of experience.
Yep.
And nowadays, with the way that the younger generations, my generation, the millennials and Gen Z operate, they absolutely will not work for the same organization for 45 years. Like, and it's just not a thing anymore. And so that's why I talk a lot about, like, to me it's an incredible bonus if we can use IoT to make our lives better, make the plant run better, make it more efficient, make things cost less. Great. But we should not be thinking of it that way. We should be thinking about it like protecting the current efficiency and capability with which we currently run for the future, and start there. How would we run it if we lost all our staff today and we had to hire all new people? How would we run the plant? Are there anybody in the plant right now that we could not run the plant without? Mm-hmm. And if I lay awake at night over this, in case you're wondering, and it's very scary to me, and I'm hoping that it becomes more of a front of mind thing for people, that the value prop is, hey, 10 years from now we want the plant to run as well as it does today. That's the value prop. Mm-hmm. Everything else is a bonus.
So Caleb, so you are working on some amazing projects, right? So you're tying in IoT and artificial intelligence and machine learning and, all of these new novel sensors and robotics and all of these things. How do you have that conversation with a client? How do you go, like, what is that conversation? Are you talking about, these buzzwords, or are you talking about kind of the nuts and bolts? Do you want to continue to run after you lose these people?
I usually talk like I talked just now. I typically don't use buzzwords. Like if you ask, my employees how often I say the word IoT or IoT, you won't hear it often. I try as much as I can to understand sort of the audience, if you will, right? So some people, IoT means nothing to them. Some people, it's the bedrock of their career, and so I try as hard as I can to be responsive, to understand the audience, that I'm working with and talking to, and understanding what their how they view a problem. Executives, I'm used to them seeing things as pure dollars and cents, and they can be short-sighted in many ways about the future. And so, I will say that in response to your question about how I talk to them is usually usually around, some potential short-term gains and synergies that can be created for them. I find that with controls engineers, oftentimes the way I talk today actually tends to resonate. They tend to see this problem. They tend to know what's happening or that it's coming. And so, but I don't know if that answers the question. I think I took it slightly orthogonal. I apologize, but.
No, I appreciate it. And before I let Vlad get on with a bunch of other questions, you mentioned sensors, you mentioned contextualizing data. You talked a bit about you guys developing a novel sensor, and I feel like we would be negligent in our asking of the questions here if we didn't kind of ask the question. You don't have to divulge anything that you're specifically doing, but maybe, what's wrong with the current vibration sensor options that we have now, and what do you guys hope to do differently?
So I wouldn't say anything's wrong with them. Certainly there's trade-offs for IEPE high frequency vibration sensors versus the, I like to call them IoT style, wireless mounted on the back of the motor type sensors. What we're developing is a different way to measure it using high frequency radar and depth cameras. We can pick up we can pick up, basically what we're doing is we're bouncing radar and optical data off of the machine. We're picking it back up we're measuring the Doppler shift, if you will, on the response. We're doing it fast enough that we can pick up the vibrations.
Okay.
What that does is that gives you a holistic view of the machine. So it's a wide field of view. So any vibration sensor you have is getting the vibration off that where exactly it's mounted on the machine, right? Mm-hmm. And that gives you a very clear view of what is going on at that point in the mechanical casing, right? And so usually you'll mount one on the casing, and you might have something, you might have one in a different spot to measure the shaft or alignment issues, and there's all sorts of places you mount them, and even different sensors, monitoring electrical, etc. What our sensor does is it can see the whole machine, how it vibrates against itself. It's like covering the machine with vibration sensors, basically. And the idea is not to replace any existing vibration sensor you have that is in a good spot that's working, but to provide to sort of tie together those points, what those individual points might tell you. This ties it all together, so it gives you a clear view of the entire machine. There's a whole lot of stuff that comes from that. I can talk about a lot of sort of knock-on benefits, but the main thing is context. So the other thing is the main thing is context. Is you can actually see how the different parts of the machine are operating against each other. You can see, for example, if you have, there's areas of the machine where you wouldn't traditionally think to put a vibration sensor on, where there are movements that affect the rest of the machine. It's a really interesting technology. High frequency radar and depth cameras are really interesting sensors, and we're still sort of researching all of the different benefits. So my answer wasn't as pat. Like I couldn't promise you that like you'll get a 30% boost in your machine health or whatever. But me, it's, again, I think a lot of these things as if you can originate data with more context, then you can then there's a lot of things you can do when you're processing the data and storing the data that allows you to it gives you more, not a lot more ways to look at the information you have. So
interesting. So you could map, I guess, like a simple example, like a case backer or like a palletizer arm, and you could essentially map the entire area and then see what's, I guess, going to fail first, or is more likely to fail, or can be optimized. Is that the train of thought with the mapping?
Yeah. Actually, that's a really great. You would, yeah. So I didn't even. So I'll tell you right off the bat that I didn't even think of that use case. But that's a great example. So you highly mobile components, right? This has a field of vision that can see the entire thing. It can see how things interact with each other, at what velocities, at what speeds versus what desired. It can see the position. It can see differences in vibration. It can see differences in speed and position. So you would be able to see a lot of things that you otherwise wouldn't be able to see and map with something like that, for sure. Because where these sensors, both of these sensors are used pretty regularly in autonomous vehicles today. and where they're used is to complement each other in the optical domains, to be able to basically map out all the different interactions in a highly variable environment that you can then provide the context of what interactions you prefer versus that you like versus that you don't think are safe, and you can make a pipeline from that. And so and if we have some time, I can talk a little bit about like how autonomous vehicle sort of machine learning pipelines work. But it really comes down to the sensors and providing the context, adding the context to the time series data.
That's interesting.
So
Go ahead, Dave,
I was going to ask, is the bigger part of the solution that you guys are trying to solve, is that more of a software? I need to tie it together in a software so that we can contextualize what's going on, as opposed to picking the sensors that you need for this new novel sensor setup?
So it requires what I'm describing requires a signal processing pipeline. So a lot of what we're doing is the signal processing of, so integrating doing the sensor fusion and the signal processing. And yes, like you said, being able to output it in a way that's understandable to either a control system or a predictive maintenance program or an analytics solution. So we're really big on like flexibility of the really big on flexibility for the end user to output it. Like are they wanting to map it to PLC tags or in order to have the PLC make decisions based off of insights? Are they wanting to get deeper analytics for later for it? What are they trying to do in their particular situation?
It could be very interesting. I was going to comment on like the application, I guess, of a robot cell that's just moving a box from like A to B. And again, I don't know if there's a solution out there right now, but I know, for example, you would enter, let's say, your end of arm tool parameters, the size and perhaps like the weight limit that it has. And then it can optimize, I think, the path based on that. But there's nothing that even like visually would inspect your cell and then again kind of figure out what's going on with your end of arm tool as it even ages, right? Because it's obviously going to get worn down, it's going to get less maybe efficient, and then you could optimize the path in real time based on that. But it does just like a thought, because I think there's going to be a lot of interesting opportunities in with that sensor, I would say.
I love talking to other controls engineers, because you always have like the moment you understand what the sensor does, you'll come up with a better idea than I did about how to use it.
Well, because I've been in those problems,
No, I know.
Spend days, if not weeks,
right,
just trying to figure out like what's going on when it's. But anyways, yes.
So, but to your point, that's one of that's why for me it's really about flexibility of outputs, because at the end of the day, the systems integrator is the one who knows what to do with it, right? Mm-hmm. I like tools. I like using tools. I like making tools. They're geared towards people who have high context to try to spread that context around a bit. So,
no, definitely.
No, I love that. And hold on a sec, Vlad. I was going to say, as we were going through this, I have 5 applications that I absolutely cannot talk about live on this show. But I will certainly be asking when you guys are done with that, because we'd certainly like to try it out. And I'm sure we want to talk about autonomous vehicles and some other things on Vlad's side. But first, we have some people to thank. So, Vlad, if you play that noise, we will go ahead.
There we go.
Perfect. And we want to thank Phoenix Contact for sponsoring the IoT theme once again. We want to talk about their PLC Next Edge Gateway as a state-of-the-art IoT device and edge computing solution. And Vlad is actually going to go pick one up from the floor, because he's got like 12 of them next to him, because he just has PLC problems, right? So this is designed for data collection in the most demanding environments. Whether you have a small machine or an entire manufacturing floor, the PLC Next Edge Gateway leverages its advanced industrial design and programming openness to collect data from any device or sensor and send it directly to the cloud service of your choice. They like to say any data, any cloud. If you guys would like to learn more, you can absolutely check out Phoenix Contact or talk to your Phoenix Contact rep or Ira or anyone, and you just let them know that Dave and Vlad from Manufacturing Hub sent you. They get tickled when that happens, and we get tickled when they tell us that that you guys are asking about the stuff that we talked about. But Vlad, I'm going to let you go ahead. Which direction you want to take us in now?
Caleb, I wanted to go back to the initial conversation we had around the learning curve, right, for new engineers, operators, whoever joins a facility. And I think the hard question, and I would say almost like two schools of thoughts that I see, is on one side, technology is making it, I would say, easier for us to understand the systems by adding more context. There's going to be a simple example, there's going to be a lot more alarms, let's say, on, again, like your case back or your filling machine. So there's, instead of like 10 alarms or it's down, it's up, there's going to be a whole list of alarms. But on the other side, there's the argument of now we have so much complexity, right? And I've even witnessed it, I would say, like in my career, where you have a single plant running on, let's say, like 5 different PLC brands. There's going to be a lot of different sensors, a lot of different protocols. So it's also making it, or I would say, like, to some degree, extending that learning curve. So do you think, or I guess, like, what are your thoughts on the technology being almost like I don't want to say like a self-fulfilling like prophecy, but also making it more difficult for someone who's coming in fresh, again, out of college or out of, again, any like school or training, trying to learn all of this in parallel, right? And I think that now that we have even big data, cloud, AI, ML, there's going to be so many components in the, as Dave mentioned, Ruth Goldberg machine, discussing our software, but that's a separate inside joke, I would say. Do you think the technology is making it more difficult, right? Like, are we creating the problem that we've discussed, which is the learning curve for new people coming into the industry?
No.
Okay.
And I'll
Okay.
so there's a lot of people that will disagree with me vehemently. There's a lot of people that like the KISS method and things like that. But I'm going to tell you something.
I hate the KISS method. But
there's a concept in the wildland fire incident guide that I learned very early on, and the statement is, it's a reluctance to simplify. Okay, we live in a complex world, and if we just think about the fact, like, everything's more complex, computers are more complex, the PLCs are more complex, right? Everything is getting more complex. And the people who are coming out of school are being trained all throughout the schooling on the latest ways to interact with something, right? We'll call them the more complex ways of interacting with
I
something.
learned on Motorola 68K, so that's,
Well, absolutely. And what they're teaching kids now, is they come out of grade school with some understanding of Python and JavaScript. They graduate from high school with some understanding, like, so I'm on the innovation board for the local school district, and the local school district has a whole AI ML track in an innovation center so like, if we take the next generation and throw them into this, like, what is this? Like, how do I wire this? Like we have to be responsive to who we're bringing in brand new to a facility. And if we say it was easier for us, 10 years ago, or we think it's less complex, it's not less complex to them. It just, there's a bias about complexity. We have to think about, like, and I probably should mention that before I was in technology, one of the jobs I did some social work. And like I said, my Valerie is a teacher. And so you can't just say, we need to keep it simple because new people who are onboarding or whatever, like, it's simple to them is not necessarily simple to you. Simple to them is, to them, what's complex is trying to understand why the plant can't interact with an iPhone app, or why they can't build an iPhone app to run the plant. That's like, they don't understand. Like, and so, and part of it is that there's a huge disconnect. If they feel like you're backwards because you're trying to keep it simple, then they won't be interested in working for you. They in general, I have not met anyone out of the last 2 generations that would just absolutely love it if everything was totally analog, and because that makes it more simple. And they've got to deal with a Windows XP machine because that makes it more simple, or just like all of these things that so we have to find a way to blend the resilience of the current systems with we have to appreciate complexity. Keeping it simple is different things to different people, and we have to be careful when we declare what simple is. That's my main issue with what's simple to me is not simple to other people. And so I don't like that motivation at all. It's more about a comprehensive education program and having an understanding of how you're going to imbue context to the most amount of people. And that involves complexity. And so I don't know if that.
I like that we agree on that point, and I've made I think a post about, I would say the keep it simple principle is often disguised as we don't have robust like education systems in place, right? So then again, as you said, I think technology is changing, and I think there's certainly a lot to learn, but that shouldn't be stopping you from adopting said technologies, right? And I think there's also something to be said about, I would say, like fear of complexity, or like fear of like poor implementation, right? Because, and I'm sure like Dave probably has those examples where you have a poorly implemented system, and then we immediately assume that it's too complex for us, right? And so obviously there's going to be a lot of issues, a lot of bugs, and then people hate that system for the poor implementation, but not necessarily because it was complex, right? And so I think there's like gray areas where, again, I would say like people get, I want to say like burned in those kind of projects. And after that, they're like, well, like, no, we don't want to like touch, or we don't want to hear anything about similar implementations because we've seen how it was done in the past, right? There's a lot of, I want to say like caveats with that as well.
I actually heard this great quote from someone very recently. He called it the tyranny of soft expectations, basically. And it was basically, the point he made was like, if we had every single person on the planet go and learn how to become an engineer, software engineer, controls engineer, mechanical engineer, and we all got to work on automating our world, then we would be done in 5 years. 5 years, if everyone was doing it. And if you say that people can't do it, then that's the tyranny of soft expectations. You're saying those people, so it's really a matter of education. It really is a matter of education, right? And people can disagree with the idea that every single person, that we could automate the world in 5 years, that we could bring people up to speed that fast, et cetera. Of course, and it's not going to happen, obviously, but we have to be careful. We have to be careful about soft expectations. Like, the simplicity concept is around soft expectations. You're basically not expecting people to learn or to be educated, or you're not doing, the whole point of instructional design is to take a concept, however complex, and make that knowledge available to a wide variety of people with a wide variety of learning styles, wide variety of, so if we're trying so hard to keep things simple, then really what we're saying is that we're not interested in proper instructional design. And how do we present the knowledge in a way that we're basically calling our staff stupid. you know, and I think in general we should always expect that whoever's here, whoever, you know, that they can be, especially in this industry, you know, this industry is full of more intrinsically motivated people than I've seen in any other industry ever. More people that are more interested in learning about how it all works together. And so, yeah.
I would say to that point, Caleb, I think that when we talk about complexity, when we talk about, you know, intrinsically motivated people in this industry, we like should call out the fact that for many people, the first 6 months or 2 years of this industry is just a meat grinder, right? There are lots of people who start in this industry who don't make it 6 months, and a lot of them don't make it 2 years. I would imagine that the attrition rate of working in manufacturing is at least as bad as in education and in teaching, and they lose something like 50% plus of people over the course of the first 2 years. So I would say a lot of it is the people who are here and are going to continue to stay here have that intrinsic motivation, or like I like to joke with Vlad, like we're all broken in the same way inside, and that's why we continue to show up to solve slightly different problems in slightly different places, or drive out to the middle of the desert to replace a Cisco switch and have to replace the entire tower because you know, lightning took it out or a cow knocked it over or something along those lines. So I think that is very good. While I will agree that there isn't very many simple things in this industry, I don't think that we need to make things unnecessarily complex. So the part that I like about the keep it simple concept is that we don't need to make it unnecessarily complex. And if we can remove 5 steps of, you know, moving software, right? So we talked about IO-Link, right? So if I can just go buy a bunch of sensors and, you know, nearly plug and play them, as opposed to having to go and set bands and kind of do all of that to every single other sensor. Like for me, that is a simple solution that costs approximately the same and in dollars up front, and is probably easier medium to long term. And if we do a good job, we either have written down set points and or the set points are remembered. And so we break a sensor and 5 years from now, someone can just go replace the sensor and we can continue forward.
And this is exactly what I mean. So I agree with you. And this is exactly what I mean about taking care about how to judge simple, right? Mm-hmm. So some people's arguments against IO-Link is that they don't believe it to be simple, right? But you just described the way in which I believe it to be simple, in the way that is easier to train and easier to provide context, right? Mm-hmm. So when so I agree with you. Yeah, unnecessarily complexity is obviously a stupid way to go. And to me, it's really understanding. Like, yes, I consider IO-Link to be a beautifully simple technology. Obviously, if you look at the spec under the hood and the software under the hood, it's incredibly complex, right? Mm-hmm. So it has to. It's so incredibly complex that it's very dense material if you read the spec, right? And if you want to really have a heart attack, read IO-Link wireless spec. So it has to do with like, so we have to ask ourselves exactly like, how do we solve these problems in a way that they scale into the future, right? Scale into the future. And I believe that what we're doing is we were willing to make IO-Link so complex under the hood, but to the end user, it is simple. And it is very nice. And I would even call it intuitive, honestly. Mm-hmm. And I also happen to like that it's very context heavy, because there's a established data model and an established way that machine can know the data model. And, so that's and that to me should be the focus, is how do we scale our operations into the future, knowing with our current understanding of what's who will staff it, who will be staffing it, how we expect the the facility to evolve, how we expect the offerings of the service that the facility currently provides to evolve, how we intend to continue to automate it, and the expectation that and how we obviously protect it from a cybersecurity perspective. And so I agree completely. I don't like unnecessary complexity. It's just, to me, it's really about who are we talking. When we say simple, who's the audience when we say simple, right?
Absolutely. I agree. And I want to give you the opportunity to talk about autonomous vehicles. We've talked about it a little bit before. You said you want to talk about it. So
I don't have to go into that. It's all right. It's not that big of a deal. But it's to me the main thing is it's really good to study autonomous vehicles when we talk about any of this stuff, whether it's data acquisition, or the sensors that we use, or how connectivity, communications, latency sensitivity, how we update software, how AI and ML is applied into the process. It's hard to argue that they, and frankly gaming, are the furthest ahead in certain scenarios. Gaming obviously is very good at simulation. Autonomous vehicles are also very good at simulation. There's a process by which they add context by default for the AI ML models, to the point where they even have a concept called auto ML, where you don't even need the data scientist anymore. You just need the context. You just need the data formatted in the right way, and you just need the context. And there's a lot of things that they don't do as well as what controls does. But in terms of where it seems like controls is trying to head, there's a lot of maturity in that space. And how the containerization software and just how that applies with latency, there's all sorts of stuff. But I think about, I like to think about like who's doing it best, right? Of any one thing. Some ways for digital twins, gaming is doing it best. Mm-hmm. You go, for ML pipelines, particularly on the perception stack, autonomous vehicles are doing it best.
Are those architectures well documented? I haven't done research myself, but can you go and figure out, I guess, which protocols they're using, how they're siphoning out the data, from vehicles?
Absolutely,
that's documented?
Absolutely. And if you want, I can tell you all, because I'm very fascinated. I'm very fascinated with how everybody does it, right? Particularly when you're dealing with physics. Like any group that deals with physics, whether it's building controls, centralized factory controls, distributed controls, robotics, autonomous vehicles, how they all try to solve effectively this very similar problems, right? It's not exact same problems, but it's close enough that and the funny thing I've noticed is that, like, I'll go to a conference, in robotics, they call it ROSCON, right? I don't know if anyone here has heard of ROSCON. I bet not. They go to different conferences, but what process controls, what controls does the best is having a deep understanding of the physical process that they're working with, or of the problem space, right? Because roboticists tend to focus on a lot of people. Funnily enough, roboticists usually don't build robots. Usually mechanical engineers do. Roboticists are usually software people who coming up with how path planning and things like that. They're usually somewhat akin to data scientists, in that they don't have as deep an understanding of the process, right, that they're trying to control. So anyway, that was a crazy side. And by the way, aerospace, the space, what they're doing in aerospace is, there's some things that they're doing very well there. In general, they're behind everyone else. Because of radiation hardening and things like that, compute is always slower. my point is I really, humility and studying things are really important parts of the culture, I think. And it's one thing I love about controls engineers. It's like the love of learning, the love of gaining knowledge that we don't currently have. So yeah.
And it's
absolutely.
I was gonna say it's a very interesting, I guess, like thought. Being exposed to, I think, like different industries and being able to, I would say, like, I guess, like cherry pick would be the word, certain components that are done better and being able to reapply them in like manufacturing or otherwise to solve problems. I guess I've not seen a lot of that because I think it's just it's a very difficult skill set, I think, to master, right?
Well, the thing that's awesome about starting in controls and things like that is if you have a deep understanding of your space and everything, what's really cool is that you'll be able to identify immediately, these are the things that we do better, these are the things that we do worse, if you're honest with yourself, right? Like, for example, in the IoT space, I hear a lot of noise about MQTT as an example, right? In the robotic space, they're wrapping DDS. MQTT isn't even part of the conversation. They're using DDS as the, like, that is and they're wrapping it with this wrapper they call ROS2. And if you look really deep under the hood, you'll find, funnily enough, that they're doing a lot of the same thing. Data model composability, passing sensor data, sometimes the same sensor data, historizing the data, being able to analyze the data, being able to apply AI/ML. How does the AI/ML model get deployed back to the robot? How do we improve it? How do we connect it to the cloud? It's a lot of the same problems. They're solving it in many ways a completely different way, and there are some things about it that are better if we're honest with ourselves. But there are some things about it that they're missing. This, like, astonishingly missing from their space, that has been around for a long time in the industrial control space. So
interesting.
Dave, I guess, what are your thoughts on that?
No, I was going to say that's interesting. I was going to say a lot of the last part kind of goes into one of the normal questions we ask everyone, Caleb, is like, what do you predict for what does the future of automation, controls, manufacturing, kind of any of those things look like? And I feel like we've talked a lot around it, but do you think we're going to have, one protocol to rule them all? Or do you think we're going to have a bunch of slightly different protocols that do similar things, but if only to make things slightly more complex and make Vlad happy, we're going to have a bunch of different protocols that do slightly different things? Like, for you, what does the future look like?
So so I talk about this, I've said this a few times, kind of around the edges of it. The future is driven by, in a lot of ways, millennials and Generation Z, right? Mm-hmm. Because that is the case, there will be expectations around the ability of the tech to be able to more quickly diagnose the problem. As it relates to one protocol versus multiple protocols, it seems like the more. So I have to imagine that what I'm noticing an increasing trend in and this is probably what IoT is all about, is the controls industry looking at what's going on in the consumer space, looking at what's going on in other, and thinking about how that can be applied, right? And if that trend continues, then yes, there will be more standardization. For example, in the smart home market, where you have the, Alexa and Google and Amazon HomeKit, they actually all joined together to create this group called Matter, if under the Zigbee banner, kind of thing. And Matter, the whole point of Matter is that if you have a device that's compatible with Google Home and it's Matter certified, then it also works through Alexa, et cetera. So and so it's not even just a protocol to rule them all. They've even made it to where it's the same, that it's that the interaction pattern for how you commission a device is centralized. How the data model is formatted is being unified. And what they're doing is this thing that I talked about. They're cherry picking the very best, like the Nest that Google bought did a damn good job on their protocol called Thread and Weave. And in order to do it, they actually studied all of the industrial protocols. They studied BACnet, Modbus, all MQTT, everything, and said, no, I don't like all of these. I'm gonna create a brand new one. There's a white paper on it, by the way, available online if you want to see like why they chose to make a new one. But the interesting thing about it is, I think that yes, as people want it to look more like the technology that's being driven on the consumer space, as that happens, you always see like a copy of it in the industrial sense. Like here, VR and AR becomes cool, and all of a sudden you see like a company that's like AR but industrial. You put on your hard hat. I won't name names, but there's a couple of companies like that, right? And then someone's like, IoT sensor but industrial, which is obviously IoT, and so it's so as that continues to expand, I guess if I'm going to make a call, it will end up being I'll call it one interaction pattern to rule them all, driven by the fact that industrial controls are I think wisely looking at ways that it's being done in other industries, and trying to apply that into the industrial control space.
No, I think that's very interesting. One of my favorite things is to kind of get everyone's thought on the future, and I am generally happy that it seems like, I don't know, the future always seems exciting whenever we get people's takes, and your take absolutely exciting, plus all of the amazing technologies that we've had the opportunity to talk about so far. Kind of the next question then, Caleb, is one of Vlad's favorite. It's career advice. And I know we talked a lot about training, right? And so from the end user standpoint, we need to put in training programs. Some of us would say they need to build digital twins so we can actually train people on things before we put them out onto the floor. But what's your advice? What is your career advice for someone maybe looking to get into the industry or mid-career in the industry, coming from a fairly unique background?
That's a great question. So I don't know if I'm qualified to give people advice on a career, because, it seems to me that besides the obvious ones like learn a programming language or learn networking, I would say actually spend some time with I would say spend some time, like go be a social worker or a volunteer, or do something to do with kids and college students. And the main reason is because understanding, if you want to build for the future, which is what we're doing, right, you do need to have a solid understanding of the psychological aspect to it. Because what I have found is that almost no solution is a pure engineering solution. Almost no, I've never walked into a plant and they're like, carte blanche, do whatever you want and we don't care. right? Now, there's been some that have been close, but once you get into it, the opinions start to, right? So it becomes more about, it very much becomes more about understanding the psychological element of what you're dealing with. Because like I said, I've never gotten to deploy a pure engineering solution without taking into account how humans will interact with it, or what humans will interact with it, and what their skill sets and backgrounds are, and what they care about, or what technologies they prefer, or how, like, I've seen lots of organizations where there's a huge disconnect between their executive branch and so sometimes, like, you end up getting, sometimes if as a controls engineer, systems integrator, like, you get placed into a room where you're like, explain to my management this thing that I can't seem to get across to them, or whatever. Like, it's this weird thing that you, like, in this space where you have to really understand how to interact with people, and how people learn, and how people think. And because that, so I guess what I would say is, make sure that you insert some really deep soft skills into your career at some point, in a very systematic way. And I mean something deep, like social work is a great example. I spent time doing social work, and that has been extremely formative. I dealt with young men ages 6 through 18 who had emotional issues dealing with their life, and had horrible backgrounds, foster care system type situations. And what you find is that there is a lot of different ways. There's a lot of different ways to approach something, but what is the way that works for the people that are going to be left with it after you're gone? And if you're good at that, then the rest gets easier.
I would say that's probably some of the most unique, but maybe some of the best career advice that we have gotten. You see, especially controls engineers who are very good at the technical, but lack the soft skills, and especially people in that mid-career. So mid-career, you see lots of control engineers who are like, hey, this guy is paying me X number of dollars an hour, like a third or a quarter or a tenth of my hourly rate that they charge the end user. I'm just going to go do the work myself, and I'm going to go make 100% of it. And they struggle and they fail because all of the soft skills and everything else that they did not intrinsically understand was part of owning an organization, or running a business, or talking to customers, or invoicing, or any of those fun things. So I think that's some very good advice.
And I think it's particularly important now, since it appears as though in general, as a society, we're worse at talking to each other. So people who can connect those dots, will go further from a career perspective.
Absolutely. Vlad, you gonna, so Vlad, every once in a while thinks about doing something completely different for a career. Has Caleb convinced you to become a social worker today?
I think it's a very interesting I guess advice. And the thought that I've always had in the back of my head is, again, I'm not sure that I guess I was thinking about social work in general, but I always thought that people lack maybe the sales skills, right? Like, the way I always thought about it is, the communication is key, right? Like, in any environment. And I think that the ability to, as you said, I guess, like, to communicate, understand what people want, but also be able to, like, position your solution as the right one in front of those people is very important. So I think I guess, like, I had a similar thought, but maybe just a different way of looking at it. And I think, again, I think that will help you a lot. But I think also the ability, again, to sell yourself, I think, to communicate to your management, to communicate, like, upstream or downstream of yourself, is extremely important. And I think you can get it through social work. I think you can get it through sales. I've had some conversations with people who have gone I guess similar type of experience by working on like a suicide hotline, being able to deal with people who are like in crisis in many ways.
That's a very good one. I mean, that's an incredible one, by the way. I mean, that's an, like, but and you're absolutely right. Like, one of the reasons why I'm here today is because I spent so much of the tech part of my career working with systems out in the middle of nowhere that I'm not very well connected. No one knows who I am, right? I'm not a like so I'm actually, I'm actually part of the reason why I'm here is so that I can become more knowledgeable about, like, who else is in this space and like thinks this way and wants to, grow it. And like, so it was basically to meet people like you is why because I've identified myself this this weakness, which is that I'm not well connected in the industry, or I don't know as many people as I probably should at this point in my career because I've been so hard at the tech. And it is a big part of it. And, especially from a learning perspective. So I like to learn from people who know a heck of a lot more than I do about things. And so that requires, talking to people and knowing people. And yeah, no, you pointed out, like, part of it is like the thing about the suicide hotline and social work. I probably a nuance that I didn't do a good job of communicating is part of it is you kind of have to know yourself to be a successful social worker. You have to understand your own strengths and weaknesses and be very introspective. And so anything that helps you know yourself really well and what motivates you and how to because obviously if you're doing a job where you're not motivated, not only is it not good for the company you're working for, but it's not good for you. And you're spinning your wheels from a career perspective. So anything that, any of those things that you can do that can help you to know yourself and to understand others is going to help you. Like Dave mentioned, running a business is pretty much 99% dealing with people with different perspectives and or different backgrounds and different understandings about the same thing even. And so, yeah, if, at a certain point you kind of have to do it, but I encourage everyone to, it really does help. And I really think that empathy and humility are the two main, hallmarks to a successful career, empathy and humility. So.
Absolutely. No, I think that those are good. That this took a slightly more serious than typical part of the conversation. But no, again, I think that this is some of the best and most interesting career advice. Every time we bring up soft skills in one way or another, everyone continues to talk about, one, how important they are, and two, generally how difficult they are to obtain. The fact that you can have kind of that self-actualization and knowledge that, hey, I'm missing something, let me go fill in the gap. That is, I don't know, maybe 1% of humanity has the ability to do that. I know a lot of very, very smart people who the answers can sometimes be directly in front of their faces, and yet they cannot solve the problem that they can for themselves, that they can very easily solve for other people. So that is very important.
Mental blocks are our number one enemy as a species. It's the problems we create for ourselves. Is just it's a yeah.
Absolutely. No, that's very good. So as we are doing our best to be respectful. No. As I told you, Caleb, and as I tell everyone, our conversations are too good, and that's how we just continue to talk forever. But no. So I like to joke that this is our hashtag not sponsored Audible segment, where I ask you if you've got a good book recommendation, and you give Vlad a book to go ahead and download. And sometimes our guests actually pull out their Audible and just start reading from it. But yeah, I know you have a good book recommendation for us, right?
Yeah, so I'm a big fan of a book called The Book of Why by Judea Pearl, particularly for people in the control space. And the reason is because it does a really good job of talking about the sort of the emergence of AI and how how the weaknesses in particular of AI, the way most people think about it. So one thing that's probably important to know is that most data scientists who think of AI, most data scientists think are very siloed in terms of their understanding of what AI is. And so even if you go and you talk to someone who you think is an AI expert, they're just describing probably whatever version of AI they're most familiar with or they were trained in. And the Book of Why does a pretty good job of explaining the different styles of AI. It advocates for a style called causal inference, which is not well known, which is good. But I think it resonates pretty well with controls engineers because it deals more with sort of the mathematics of causality versus correlation, which is what most data science is, most AI is. And so it's a really good, I consider it to be the best introduction into like how to think about the ups and downs of AI. And since at the end of, and since probably everyone here, the management of the plants that they deal with probably wants to run the plant on AI. It's probably a good idea to be conversant in what the problems of that are, and also how it can't just be solved with, you know, throwing sensor data into a time series database, historizing it, dumping it into a Jupyter notebook, and you know, writing some Python and coming up with some magic. Like it's a thing full of pitfalls, and it's good to understand, particularly for this industry, since we deal in, you know, very real world scenarios. We are what's connected to the actual physical infrastructure of society, and so we're the ones who need to understand the best about what does and does not work in this space. So,
that is
April. Yeah,
very interesting. I think you've convinced me. I think I'm going to go ahead and read that. I do a lot of reading, kind of in and around the AI space and bias and kind of trying to understand, because at the end of the day, it's humans that program this. And so everything that we build are going to have the same intrinsic biases that we have, whether intentional or unintentional. And the biases that we have really just get shown bare when it's a computer making as logical a logical decision as humanly possible. But no, I think that is good. And I think that all of us are excited to watch as we create more applications, realistic applications within this industry. And then the real fun of having data and contextualizing data and spending years scrubbing the data so that we can dump it into a database and hopefully, you know, cross our fingers that the algorithm works. Yeah, we're somewhere between weeks and decades away from that happening, which should be very fun. But last question for you, Caleb, and you kind of alluded to it before. So the last question is, you know, who should reach out to you? Who do you want to connect with? Who do you want to talk to? Are you guys hiring? Are you guys looking for jobs? You kind of alluded to the fact that you are here talking to us and you know, more recently on LinkedIn because you want to meet people in the community. So who should reach out to you?
Exactly. I mean, I would say pretty much everybody. I mean, we're like right now, I'm trying to build up my skill of being able to sort of connect with people in this space and to sort of learn, you know, all the different problem spaces and use cases people have. You know, definitely interested and willing to take, you know, interesting work for people. You know, if people have, you know, a problem space that like is where they want to apply sort of, I'll call it the latest and greatest, you know, maybe unique way of looking at things, then definitely. But, you know, I'm really interested. I'm really trying to, like I said, knowing thyself, I'm trying to build up my skill set of being able to connect with people in this space. And so I'm trying to do better at like, you know, work, you know, engaging with people, you know, because I'm my inclination is to be deep into the tech, and I oftentimes miss I miss all of the knowledge and wisdom that comes from other people who have themselves been deep in the tech in a completely different way with completely different scenarios. Vlad mentioned a couple scenarios I didn't even think about for the thing and that happened in a very small, short period of time after 30 seconds of me explaining the thing. So obviously it's clear that there's things I'm missing. And I right now, I really like to talk to people. So I don't know how to, if that I can't get more actionable than that, I guess, but that's, but.
Awesome.
No, I love that. I think that's good. So I will make the request. Hey, if you guys are not connected to Caleb, you can connect through the show, through any of the clips that you're watching. If you're watching live right now, you can connect with him, and we will go ahead and drop links on YouTube. It has been an amazing conversation every time we're talking. And man, we haven't even got to how we're going to build Skynet by connecting your robots through IoT and having the autonomous cars doing that. So we will have to commit to having that show again at some point in the future. But thank you, Caleb, and thank you everyone for this amazing conversation as we quite literally continue to push the bounds of IoT in this theme. I will ask again, if you guys are not, please feel free to subscribe to manufacturinghub.live. You guys can get emails with about an hour reminder of when we're going live. Connect with Vlad, myself, connect with Caleb on LinkedIn. You guys can subscribe to Solus PLC and follow the Manufacturing Hub Network on LinkedIn. And beyond that, if you're listening to us in podcast form, again, please go hit the subscribe or the follow button, rate us 5 stars. That helps for a bunch of reasons, and more of you continue to find us every week, which again shocks Vlad and I like nothing else. But we will say thank you to everyone listening in, and until next week, we'll see you guys soon. Bye-bye.